My name is Darren Tua. I am a senior here at SIPI. I am a member of the Hopi tribe, and this semester I signed up for the Swarmathon competition.
Hello, my name is Brian Doney. I'm part of the network management program at SIPI. I'm from Navajo and I'm from Arizona.
My name is Bradley Kay, and I'm from Arizona, Burnt Corn, Arizona, specifically, and I'm in the pre-engineering program.
The goals of the competition are to simulate autonomous rovers to collect resources prior to having the first man land on Mars, so they will have resources ready and available for them. This competition is from UNM, sponsored by NASA, and this is the first year of the competition. And our school was selected to compete in the physical competition, which is going to be held at Kennedy. Right now, our swarmies have an Intel NUC for the brain to run the whole rover. There is a camera attached in front to detect the April tags. Also in the front, we got three ultrasound detectors for collision avoidance. The names of our swarmies are Chappie, Eva, and Wally. The sensors on them as well have GPS, IMU, and compass modules. Our school was actually the only school to go to UNM and build our own swarmies. With that, we got a better understanding of how our swarmies work. We got to see the construction and how each part is put together. So when we had some issues throughout the competition, we were able to fix it, take it apart with the understanding of how to put it back together again. And then since this being a first time competition, we collaborated a lot with UNM, and UNM actually came over to our school to help, for us to help them with a better understanding with the code. And they used our arena to test their rovers, which was a failed test in the beginning. But as things got better, and we were able to improve on the code and help UNM update their codes.
We built the full-scale arena area for testing the swarmies for the competition, and we found a lot of problems with the sensors and everything else. We found a lot of problems, which is the swarmies don't behave like they do in gazebo and work too well in the simulation. With the challenges we faced a lot, especially with the swarmies instruments aren't precise. It gave us a lot of different readings, like the wheel odometry wasn't accurate for over a long distance, and the GPS error margin was too big, basically 10 meters. With the compass, it doesn't really display the true heading. The ultrasonic sensors will interfere with each other. Basically, all the sensors were not accurate when we first got them. With all the challenges, and we've seen a lot of rewarding part of it too, quite a bit, learning from each of them. Even the programming, it always didn't really transfer to real world from the simulation. And yeah, that's basically what we found out.
Some of the sensors weren't out of the box ready. Some of them took calibrations and had a bunch of errors in them. Our GPS unit, the margin of error was 2 to 5 meters off, so we could say our rover was there, but it was 2 meters left or to the right. Also, the wheel odometry was off. Sometimes they wouldn't find their way back to the home tag, and sometimes they just get completely lost in the arena. So basically, the sensors are not accurate out of the box. We can't just turn them on and expect good results in the beginning.
In the beginning, we tested many search patterns. I think in the beginning we had a half circle design, so it would travel from one point and start circling around the home base. But as we soon figured out, we tested it in a virtual gazebo. But after a while, when we tested out in the physical world, we found out it was nearly impossible because of errors and everything. So we decided on something more simpler, so it would not we decided on a spoke design.
We decided on the spoke pattern because it was really too slow moving throughout the whole field for the swarmies, and basically we had to keep everything close to home. Basically, what we had to do, so we don't want to lose our swarmies. Because the pattern is pretty useful in a small radius.
So for every trip out, it would travel out 3 meters and come back. This would prevent from becoming lost or in recalibrating every turn. And once done with a small radius of 3 meters, we decided to have them do it again, but at 6 meters this time. There were a lot of challenges during this competition, but it was rewarding to see the end result.
Well, in conclusion, we had a lot of challenges and a lot of good results that came out of this. We learned a lot more about ROS and how ROS is run, pretty much how our codes were written in different codes, and how ROS got to help us apply all of that to our swarming. Also, our team will be traveling to Florida to Kennedy Space Center for the physical competition, and we're really confident in our swarmies and our search pattern and our codes because of our preliminary findings and how our codes run and how we were able to test them out in the physical conditions.